here is, well, what happens to our system when we've got an object that's going to move not just in one direction, maybe up and down, but might move both up and down and side to side, moving in two directions. But we're still going to restrict ourselves in most situations to constant acceleration because it's kind of easier to work with. And basically, the whole reason that we spent time a couple of weeks ago on vectors is so that we could do the motion in each direction independently. And so you can have a constant acceleration in the x direction and a set of kinematics equations, and a constant acceleration in the y direction and a set of kinematics equations. And those two directions are entirely independent in some sense. They are actually secretly tied together by this variable right here, time, right? Because we're describing the motion of a single object kind of as it moves up and down and it moves side to side. You can kind of advance time at the same rate in both directions and connect the two sides up like that. But you can see that our list of things has now effectively doubled. Okay? Before we had this list of things, and now we've got all of those things except for time for both the x and y directions. And that can be a lot. And there's good news on kind of limiting how many things that we need to deal with. And that good news is if the acceleration is really constant in both directions, then I could just choose to put my coordinate system in the direction that the acceleration is pointing. And at that point, I now have constant acceleration in one direction, and I have acceleration that's 0 in the other direction. And that'll be a really common trick that we take advantage of. It reduces our slate of equations to something that looks like this. We've actually only reduced our kind of variable total by 1 by knocking out the acceleration in the x direction. But you can see that the equations themselves on that side are a lot simpler. We don't have that quadratic t squared floating around it. We can actually take one further step here, which is often the kind of two-dimensional acceleration, constant acceleration problems that we are interested in dealing with are free fall kinds of problems where there's an object near the surface of the Earth which is only moving under the acceleration due to gravity, at which point, whoops, we know what the acceleration due to gravity is. It is negative g. It points in the downward direction. It has this value, which we call little g, which if you want a number for, you can use 10 meters per second squared is a really good number to choose for this class because it's really easy to multiply and manipulate the number 10 if you need. All right, that is what we will be doing with two-dimensional motion all week.